Okay, in lesson 8, we're going to talk about congruent triangles, and I mentioned in a previous lesson that when you get to congruent triangles, congruent means same size, same shape. Okay, so this means that all corresponding parts, all the angles, all the sides are congruent. When triangles are congruent, we can write a congruency statement, and a valid congruency statement must match all corresponding sides. So as you can see here, all right, A has 1 mark, B has 2 marks, C has 3 marks, and so you would if you wrote your first triangle, ABC, and you can write your first triangle any kind of way, but then your second triangle has to match up. So D has 1 mark, E has 2 marks, and F has 3 marks. All right, so A must correspond with D, B must correspond with E, and C must correspond with F. So if I were to write this as triangle BCA, then I would need to write this B goes with E, and then A goes with D. Oops. That would be triangle EFD. All right, so they have to correspond with one another. Now, CPCTC. So typically in a geometry class, you're going to spend some time, especially once you get to congruent triangles and similar triangles, you're going to spend some time. You might also do this with parallel lines and stuff like that. You're going to do proofs. 2 common proofs are probably the most common and probably the most accessible to your students. All right, but they can get a little bit more complicated. In a college class, you would see like paragraph proofs and such and other things. I tried flowcharts once, and to me, it made a lot more sense. However, my students didn't feel the same. Okay, so given what this is saying is simply what the definition said, which that CPCTC, so you would prove triangles are congruent, and then you would go say something else because corresponding parts of congruent triangles are congruent. If you know 2 triangles are congruent, then we know each pair is congruent. So if you're trying to get a certain side, trying to say a certain side or a certain angle is congruent to one another, sometimes the easiest way to do it is to go ahead and prove that the triangles themselves are congruent, and then you can say, hey, these 2 parts are also congruent because of this. But that comes up, CPCTC comes up in like the proof situation. So on number 1, we're going to use the idea of congruent triangles to solve this. So UVW, so let's say we got U, we got V, we got W, corresponds with TSR. So T gets 1 bar, S gets 2, and R gets 3. Okay, so that means the sides in between the sides in between them are going to line up as well. So let's see, let's do 12x minus 7 equals, so 12x is UV. UV is the 1 to 2, so that's going to be TS, so that equals 53. And then you solve that. 12x equals 60, x equals 5. Okay, and then you do the same thing with y and z. So y is 5y minus 3, or 33, equals, all right, so that's 3 bars to 2, so the RS goes with 57. And then z is 3z plus 14. And the only side left is 50. So let's solve these. 5y minus, or equals, let's see, adding, this can be 80, 90. So y equals 18. And then 3z equals 36. Z equals 12. Okay, so easy peasy. As I said before in the previous lesson, the geometry is the setup of the problem, and then algebra takes over. So how good are you with your algebra skills? We're going to do the same thing on number 2, PHS. So we got PHS, CNF. So C gets 1 bar, N gets 2, and F gets 3. Okay, so as you can see here, we have a 36 and we have a 115. So what's the other angle going to be? Well, you know that the inside of a triangle adds up to 180. So 180 minus 36 minus 115 equals 29. All right, so that's going to be important as we start to set this up. So that's going to be 29 degrees. All right, so let's see, 6x minus 29 equals, h goes with n, so it's going to be 115. All right, y, you got 3y minus 1. F goes with s, and we just found that to be 29. And you would need to do that calculation from the 180 degrees before you set that up. And then z is going to be 4z minus 32 equals, and we said that other angle is 36. So 36. All right, so let's solve each of these. 6x equals, all right, so that's going to be 144. X equals 24. All right, 3y equals 30. Y equals 10. 4z equals 68. Z equals 17. All right, so once again, how good are you at algebra? That's what we want. That's what you're really going to find out from your students, is who's good at algebra and who's not. Okay, so that's how we use congruent triangles to solve problems. Now, ways to prove triangles are congruent. All right, this as far as K8 goes, you are probably not going to go much further than what we're going to talk about here. It's just showing, using figures to show this to be true. You may not, until you get to high school, actually get into whether or not, like, showing and proving these things to be true. All right, so you have side, 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 angle, and angle, side. So if you know two angles, you can find the third, which is why ASA and AAS really go together. And then if you have a right triangle, if the hypotenuse and one of the legs are congruent, then you can prove that triangle is congruent by hypotenuse leg. Okay, so let me show you exactly what this is. So you have, so if all three sides are congruent, that would be side, side, side congruence. If you have two sides are congruent, and the angle in between, and it's important that that angle be in between those two sides, then you have side, angle, side congruence. Now, if that angle is somewhere else, then that would be SSA. And if you rearrange the letters, that spells a word that we don't typically say, especially with younger students. So one of the things that I used to say is SSA is not a way. And then, of course, some smart kid is going to know what the other, if you rearrange the letters, what it's going to say. And I would just say a SS, we don't cuss in geometry. So a couple different ways you could say, hey, the angle has to be in between for it to work out. If it's not, then it's a problem. And then, of course, if you have two angles that are congruent, and the side in between, and again, it has to be in between for ASA, angle, side, angle. But it doesn't have to be in between to show congruence. It just has to be in between to say ASA. Because the second one is, if you have two angles and another side, well, again, because the inside adds up to 180, if you know two angles, you can find the third. So ASA and AAS are like cousins or sisters or whatever. They're related. If you know two angles, you can find the third inside of a triangle. So does the side have to be in the middle? Not necessarily to prove congruence, but whether you want to use angle, side, angle, or angle, angle, side, that's what dictates it. And that's where, if you're teaching proofs, that's where you want to be a real stickler, because if you have to be able to prove the angles are congruent in order to say something. So you would want to make sure that they're using ASA and AAS appropriately and not interchangeably. Even though they're connected, they're related to each other. You have to prove something in order for you to be able to say something. Like, so if I had a situation like this first figure ASA, but I tried to prove it by AAS, I would need to go prove that third angle before I said that. All right, so not to get too deep in the weeds, but that's kind of the idea. They are not interchangeable, but they are related to one another. And then again, if you have a right triangle, you can prove if one of the legs and the hypotenuse are congruent, then you have HL congruence. All right, so let's look at some examples and see if we can prove triangles are congruent. All right, so for number 3, let's see. We have 2 angles, and any shared side is understood to be congruent. So you have angle, side, angle. So this angle, side, angle, congruence. All right, 2 sides and a shared side are congruent. So that's going to be side, side, side congruence. All right, 5. You have 2 angles and a third side that is not included. So this would be AAS congruence. All right, you have a leg of a right triangle and the hypotenuse is shared. So that's going to be HL congruence. Okay, you have 2 sides. And if you're going to use 2 sides, the angle has to be in between. Now, you know all vertical angles are congruent, but because that angle is not in between the 2 sides, so it would need to be right here, and it's not. We don't know those 2 angles are congruent, so we cannot say these are congruent. So this is not congruent. All right, remember that these little arrows indicate parallel. So if I got parallel, that means I know certain angles, like this angle in the corner is congruent to this angle right here because it's corresponding. Okay, and then that results in angle, side, angle. All right. Here, shared sides are congruent, so we have side, angle, side. On 10, shared sides are congruent, so we have side, side, side. 11, we have hypotenuse leg, but of course, vertical angles are congruent, so you could also prove it a different way. But this is going to be hypotenuse leg. You could say angle, angle, side, but typically with a right triangle, you want to use a HL if you can. All right, again, vertical angles are congruent, so this would be angle, angle, side. Okay, we know one set of angles on 13 is congruent. We know the shared side is congruent, but that's all we know. So that is not enough information to say congruent, so this is not congruent. And then the last one, again, we have parallel lines. So that means this angle and this angle are the same by alternate interior. Same thing here. Alternate interior. And then, of course, vertical angles are congruent. So you have your choice of angles. You also have choice of sides. So this could be any of the following. This could be SAS. This could be ASA. Or it could be AAS. So sometimes it works out this way where you have multiples that you can use. So, all right, so that's the idea. I hope you got something out of that, and I will see you in the next lesson.